How do you like your eggs? Right. It's a very important question, you see. Some people like them boiled. Some people like them sunny side up. Some people like omelets, maybe scrambled. If you're fancy, you like a poached egg. Generally, there are no wrong answers to this question, how do you like your eggs? Unless you say raw. Now, what if I tell you that you can cook an egg purely by mixing it hard enough, like in a blender? Now, why would this happen? Why would rapidly mixing an egg cook it? When scientists looked deep into the mysteries of the universe, they were surprised to find that just like the Constitution of the US, in the eyes of the universe, all energies are created equal. And the energy of the universe, for the universe, by the universe, shall not be destroyed on the face of this earth. It can only be transferred. So let's test this law that science nerds call first law of thermodynamics. Take your right hand with me and start waving it. What you have right now is the energy of movement. Take your left hand and bang it together. Once more. Once more. Faster. Thank you. What you learned here is that you can change the energy of movement to energy of sound. And you might feel slightly warm in your hands. That's the energy of heat. That's what happens with the eggs, right? This means that you can cook your eggs if you really whisk it hard enough or for long enough, right? But this means that you need a lot of muscles to cook your eggs, right? And you need a lot of eggs to make your muscles. This is the circle of life. Actually, this is the circle of life. It's a cell, the smallest unit of life, and it contains within itself a huge amount of complicated stuff, right? And this stuff is also extremely important. But because these cells are just like us, they age like us, they work like us, they die like us, they catch diseases. We try to repair them with medicine, but imagine if scientists could create our own cells, if we could have our own synthetic cells, not made of plastic, but robust, more stronger, better than the cells that nature gave us. Now, when I talk about artificial life, it sounds scary and sketchy and somehow wrong. But humans have always been wrong, haven't we? Our relationship with nature has always been of a weird one. Life gave us lemons, and we made bionada, lemonade, the ultimate form of lemons. Life gave us millions of years of evolution compressed into one beast, which is 1 horsepower. We made chariots. But life never understands that we want to go fast. We want to go really, really, really fast. So we created 500 horsepower BMWs so we can go faster. It's not us who are doing something wrong. It's just life. It doesn't understand. And fairly, the principle of making a synthetic cell is pretty much the same. We don't mind the cells that nature gave us. We want to make them better. We want to make them faster. Now, cells are extremely complicated. To the point where not all scientists even understand cells. So, the only way we do justice to it is to represent it with an extremely complicated model. So I'm so sorry that I'm going to present this extremely complicated model in front of you. A balloon. Now, just like the cellular membrane, the thing that covers the cell, this balloon has a membrane that covers everything that is inside of it. Anything can be inside of a balloon, right? Air, water, the gender of your baby. Now, this brings us to the question of how important is this membrane, right? And there's only one way to find out. There's only one way to find out how important a membrane is, right? And the simple demonstration is very important. These membranes create other things which are also made up of the same membranes. So the first step to make a synthetic cell or a synthetic life is to start with making this membrane. And Scientists have already done this. That is a real picture of the membrane which is made synthetically in a lab, right? Looks amazing, it's a circle. Now, these membranes are made up of really tiny molecules called lipids, right? And these are kind of alive, not really, but they are moving all the time. They're just like a two-dimensional liquid. Just like water is a three-dimensional liquid, they're a two-dimensional liquid. And when you make these molecules, or when you make these synthetic cells, you want a way to control them, right? And to control anything, you need to transfer energy. What we've just learned is that you can transfer energy to a liquid by using a blender, right? The only problem is the liquids I'm talking about here are very, very small. So we need really, really tiny blenders. Now, a very good thing about this world is we have Nobel laureates in chemistry, and they can make these really tiny blenders. And when we take these really tiny blenders and use them to blend the liquid, the two-dimensional liquid that we're talking about, we can actually start stirring them up and put some energy in them, right? And that's the way that we can provide them with energy. Now, what happens if we test it? Oh, before that, I talked about really, really tiny, right? To understand how tiny, just imagine if the world was 100 centimeters. If this earth was 100 centimeters, extremely unfortunate for most of us, but then these motors would be 1 Ferrero Rocher wide. So really tiny as compared to the earth, so really tiny as compared to us also. Now, what if we put them inside? The thing is that they require an input of energy to start rotating. Just like the blender requires electricity, these require light. So the moment I start shining light on these, they will start transferring energy, and then we can see what happens. So that's enough light, I guess. And what we see is that we can control the shape and size of these cells that we created. And this is the beauty of having a machine that can transfer energy into something so abstract that we created. Now, this is just the first step of creating a synthetic life, the first point of control. And imagine with this much amount of control, we can really enter as humans into the superhuman era. Now, I don't mean superhuman killing machines. I also don't mean superhumans like a human with wings or people who give high sixes instead of high fives. We hate those people always. But what I mean is a humanity that can prevent diseases that affect millions of lives or even defeat aging. So the next time someone asks you, how do you like your eggs? The answer is blended.
Yusuf, Qutbuddin! Das ist gefährlich. Yusuf Qutbuddin from the Origins Cluster.